Okay, so now we got our new mechanical seal. Open up the box, and every mechanical seal, generally there's going to be a mechanical seal drawing in there. It tells you what pump it fits. It gives you all the dimensions of the shaft. The stuffing box board gives you a lot of helpful information. Generally speaking, it'll have a bill of material over here. It'll tell you the materials of the seal that you're getting ready to install. This is a mechanical seal. It's got various cautionary notes on it. You know, take note of them. Read every one of them. This seals, it says it's been tested at the factory to 25 psi. They put this on a mandrel. They put clean compressed air to it, and they shut it off, and they make sure that it doesn't leak down too fast. So it passed. Then they got various shipping plugs in here. Notice here, now this is something that people run into all the time. They call me and they say, well, what are all these ports on here? Well, go to your mechanical seal drawing, and it'll show you a picture of the end view of the gland, and it'll tell you which one is the flush port, which one is the quench port, which one is the drain port. Sometimes they have a vent port. This one has 3 ports, drilled in tap ports. On your drawing, you'll see this is the flush port. Flush means that the fluid goes into the process. The quench port and the drain port, well, the drain, that's pretty self-explanatory. If your seal leaks, you want it coming out your drain port rather than coming out the back and slinging all over the place. The quench port is also on the atmospheric side. So both the quench and the drain are on the air side of the mechanical seal faces. So, and this happens all the time, if you hook up your flush water to the quench port or the drain port, seal's going to spray all over the place. So just take note of which ports are what. So we'll remove these shipping plugs, keep everything clean. They've got a warning decal that says this is where you have to tighten the drive collar to the shaft. I'm going to go ahead and remove this because we're going to basically go through a full installation on a brand new seal. All right, first thing I do is I check very closely back here these drive lugs. You know, the guy at the factory, hopefully he was on his game that day, and hopefully he's got these things properly secured. Well, so I get an Allen wrench and I look at it, make sure everything looks good. I come up to these little setting clip devices, make sure they're good and snug, because if they're not good and snug, then they won't properly center things. Okay, everybody's good and snug. And then I'll look at the set screws that are going to bite down in the shaft. Now in this case, there are 4 of them, 4 cut point set screws. Bear in mind, there are also 2 locator set screws. These are at 180 apart. Don't mess with those. Those, as the guy's assembling them, he just snugs those down, barely, to locate the drive collar. You do not need to tighten these to the shaft. You tighten the cut point set screws in the case of these standard cartridge seals that bite down to the shaft. There are various mechanisms as far as securing the rotating portion of the seal to the shaft. They have shrink discs, they have ring fetters, they have set screw driven collars. This is the most common. I check to make sure that the set screws are backed out enough to where this one's in just close. I'm going to back it out just a little bit to make sure that when I slide this thing up on the shaft, it doesn't touch off. Check your gasket on this side. Make sure it's fully seated in this metal here. A lot of times they'll have a female register here where the gasket will stay centered. Here's your O-ring that seals to the pump shaft when we install it. It'll be installed like so. I put a compatible grease on that O-ring, lube it up. I keep the shaft clean. Okay. And by the way, make a habit of installing the mechanical seal on the shaft. Don't do like has been done on some occasions and install this seal and tighten down on it, because look at this. This is a shaft centered seal, but look what I can do. See how it'll move all over the place? So if you tighten it down here, it's gonna be out of center. So the proper method is to put it on the shaft. And so I'm gonna go ahead and install this. Now, bear in mind the quench port, look on your seal drawing, but it's normally at 12 o'clock. Okay, we're gonna lubricate the O-ring a little bit and install this guy. I got my quench port at 12. Okay, so there's the seal on there. Now we're ready for our stuffing box. Okay, secure this with the nuts. Okay. Go ahead and snug those up. Okay, now we grab our nuts that are going to secure our seal and our washers. Put these nuts on. And at this point, this is a shaft centered seal. And so it's okay to go ahead and tighten the seal gland to the stuffing box. What we don't want to do is we don't want to tighten the set screws to the shaft, because once we assemble the casing, put the impeller on, we're going to adjust the impeller clearance. So the last thing you do is tighten down on those, in this case, 4 set screws, remove the clips, and you're ready to run. So I'm going to go ahead and tighten these nuts. And then I'll come back, we'll put the impeller on, we'll do the clearance. Okay, so I got my seal up here, snugged down by hand to the stuffing box. This is a Teflon gasket that we're compressing between these two surfaces. So while we've done the dial indicator reading to make sure that our face reading is good, if we tighten down this gasket too much, we can. So you want to do it evenly. You want to bring it up slowly. You want to cross 180 from one bolt to the next. And for instance, if it's Teflon, you just want to tighten it enough to where you're going to get a good seal. There's no reason to extrude the Teflon out to where the gasket's completely shot. So we got this guy tight. All right, so our impeller has a O-ring in this case that seals to the pump shaft here, threaded here. So this O-ring's bad, but obviously you'll want to use a new O-ring every time. Little anti-seize here. Don't get the anti-seize anywhere near the seal. Seal faces do not like anti-seize. Anti-seize here. Put the impeller on. turn the shaft in the direction that the pump's going to rotate. Okay, and then we use our shaft wrench to fully tighten the impeller, because before we go adjusting that impeller, we want to make sure we're good and tight. And the way we do it is we'll put this on a metal table, and imagine that this metal comes out to here. And we'll take this impeller and we will, in this case, let's see. Yeah, actually it'll go like this, sorry. So it'll come over here, boom, and we slam it down on the table. The guys in the shop call them slam wrenches for that reason. But anyway, so we get this guy fully tightened. Notice we still hadn't tightened down our set screws. So then we're off to putting the back pull-out assembly in the pump in case you left the casing in the field, or if you brought the whole pump back to your shop, installing the case. This is pretty heavy. Get the bolt in here. Okay. And we get all our bolts started. And by the way, it really helps to have this pump, when you're doing this step, on a flat table. Now this table is not flat, but if you've got a granite rock that's been polished off flat, that's what we assemble them on. Because that way, the bottom of your machine pump casing feet and your bearing housing feet will be parallel with one another. Minimize any chance of any soft flip when you go to mount this pump on the base plate. All right, so bottom line, put all these guys in. Again, we tighten them up gradually, crosswise. We're compressing a gasket, important that it's even. And then we're gonna adjust the impeller. So this little deal back here on this style pump has a thrust bearing carrier here, excuse me, that has 3 pull bolts that pulls the housing this way, and 3 push bolts with lock nuts on there. So this is a slip fit between this part and that part, so bear in mind that if you over tighten one side, you can actually cock the housing in here. And I've actually seen people to where they are not paying attention and they actually lock the bearing up, because the internal clearances on the bearing are very little. This pump is a little different in that here's your housing here, and this is a machined thread between this bearing housing here and this larger housing. So in this case, it doesn't have any push bolts, pull bolts. It has 3 little keeper bolts that once you get the impeller set to the right place, then you snug those up and that's it. The cool thing about this is because it's threaded, there's no, or the potential for putting the bearing in a bind or misalignment is minimized. Another feature, you know, this, we talked about this guy being an open impeller pump. Well, in this case, here's your impeller in this pump, and this is a radial clearance between the mouth ring of the casing and the impeller, and then this is a front shroud. Well, it's open on the back side in this case. So the running clearance is between, on this pump, between the back side of the impeller and the stuffing box. Okay, just consult your manual to figure out, you know, what you got and what you don't have. So the first step, we've already verified we've got over 200,000 worth of the first step is to get this to where my pull bolts can pull everything forward and we can set it properly. Okay, so I want to back these guys out pretty much all the way. They're the push bolts that push it this way. Okay. Okay, so what I'm going to do is I'm going to tighten one of these screws until it starts touching off. So I'm going to be rotating the shaft. That little noise you're hearing is actually the shaft turning inside the mechanical seal. All right. Well, look, our gap between the leading edge of this housing and this is almost completely gone. So I'm probably not going to be able to adjust it to the correct running clearance. As I say, that casing's completely worn out. But I pull it forward and till I scrub, and then I barely back off. So we pulled it forward, and imagine now that it's scrubbing, and we're gonna back it off. And what helps too is to have a dial indicator for this step, just like so. Because once we're scrubbing, that's our 0, and then we back it out whatever the manual says, and then we lock it. So, since we're scrubbing, we're gonna now back it out. All right, set our indicator at 0. And so we use one of these jack bolts, push bolts, and we, again, imagine we're touching off down here. So we're going to pull everything this way. All right, here we go. There's 10 thousandths. Let's assume your manual calls for 15. So we're going to set it to 15. Boom, 15. Make sure everything turns free. Then we're going to take these other push bolts and we're going to run them up to where they just barely touch off. Literally by hand is the best method because you don't want to move the shaft. Okay, touching off. This way. Oops, back that nut out a little more. Okay. Now, we want to very evenly snug up on the pull bolts. Now I'm gonna barely snug back up on these guys. I want to make sure I don't have any play. Okay. Check this one more time. Yeah. I don't want to go crazy on tightness there because, like I say, you can lock it back. All right, and then these little jam nuts, run them down, snug them up. You're good. You're ready to go. So the seal is tight to the stuffing box. Imagine that all these bolts are pulled in and fully compressed. We've set the impeller clearance. So we're ready to go. Now let's set our seal to the shaft. So this seal here, there's one of the set screws. And now bear in mind, this is the only thing holding this seal to the shaft. So these set screws that I'm getting ready to tighten need to be really tight. Because if your set screws lose their grip, what will happen is the pressure in the pump it'll cause the seal sleeve to start spinning on the pump shaft, and it'll also, the pressure will push the drive collar back, and this gap here will open up to a larger gap than what it should be. And what that does is over compress the seal faces. The seal faces lose their lubrication, heat up, break, you're right back in your pump. Okay, so we're gonna go around here, we're gonna tighten all these guys up. I'm gonna get a pair of channel locks, give me some extra oomph. I'm gonna tighten them even. And once I got them all tightened, then we remove these clips. Your seal is now locked to your shaft. Okay, so and by the way, notice you see that the width of that piece right there. That is the dimension on this steel between the back of the gland and the drive collar. And in this case, that gap should be 62 thousandths of an inch. So again, if you come up to a seal and a seal has failed and that gap's bigger than what it should be, then that's a serious factor. All right, so we're going to go ahead and remove all these clips. The very last thing, I guess, is thinking about a seal flush. So depending on the design of the stuffing box, depending on the service you got, we got all different kinds of seal flush plans. We have a booklet that shows what seal plan they assign API flush numbers to it. A very common one is a plan 11, where you come off with discharge pressure. In this case, we would have a drilled in tap port here. You screw in an orifice to control the pressure and the flow rate being delivered to the seal, and you flush in with high pressure fluid. Consult your seal supplier as to what flush plan they recommend. Many times, if it's a customized drawing, it'll say over here what flush plan to use. In this case, this is a generic seal that fits all different kinds of 1 3/4 shafts. It's not application specific, so there's no flush plan indicated here. But you need to think about a flush plan. If you just plug all these ports, or plug the flush port, then there's really no circulation of the fluid back at your seal faces, so it builds up heat. Will it survive like that? Yeah, I mean, I've seen tons of seals out there that run with no flush plan. Depending on the style stuffing box that the pump manufacturer has, if it's a taper bore stuffing box, then fluid can come in the seal area and go out. So you do get some flow and you don't necessarily require cooling. Here's another example here. Here's a taper bore stuffing box with little speed bumps, and that minimizes the amount of swirling that the fluid does back here, because if you're pumping a lot of solids, it can erode this part. So those speed bumps knock that out. But this is a self-venting. See how the bore down there here is smaller than here. So any air bubbles when you initially flood the pump are going to go out. And also, fluid is able to come in the seal chamber area, cool the seal faces, which in this case are right there, and then go back out. This style impeller has balance holes in it. So fluid comes in here at suction pressure. Through centrifugal force, the pressure is increased. Then high pressure fluid comes on the back side of the impeller. This is the running clearance in this pump between the back side of the impeller and the stuffing box. And so then you've got pressure somewhere in between suction pressure and discharge pressure coming into the seal chamber. And then these are balance holes which allow that fluid to go back to suction pressure. So you're getting plenty of flow back there in that case. Hot water is a unique situation. Any fluid that's close to its vaporization point, basically a mechanical seal. The essence of a mechanical seal, whether or not it's going to last at all, is the fluid film in between your seal faces. If that goes from a fluid to a gas, i.e. it flashes, boils, that's going to do damage to your seal faces. So maintaining a stuffing box pressure of at least 25 psi over the vapor pressure of your fluid is a rule of thumb. If you're running carbon against silicon carbide, for instance, that's more tolerant of being on the edge of flashing compared to silicon on silicon, say for instance if you're dealing with a slurry seal. Okay, that's about it. Hope this was helpful. Thank you.